Let's see how we all did. Remember, if you don't check at least one corresponding coordinate with your rule, you're being a fool. Don't be a fool. Check your rule. So check one corresponding vertice. So taking a look, 12, we have our pre-image to our image. X, y is mapped to y, negative x. And hey, we have the same coordinate rule over here. X, y is mapped to y, negative x, because a 90-degree clockwise rotation is equivalent to yeah, that's right, 270-degree counterclockwise rotation. And I checked on 12, 1, 2 went to 2, negative 1, and negative 1, 0 went to 0, 1. Wonderful. Moving on to 14 and 15, your images should look similar to this. And they also have the same coordinate rule of x, y being mapped to negative x, negative y. Because a 180-degree rotation, the direction does not affect. So taking a look at the transformations that create these type of shapes, segments may change, slopes may change of the segments, reflections and rotations. The corresponding angles have the same measure. That's all the transformations we've talked about: dilations, reflections, rotations, and translations. Corresponding segments have the same length. That's only in a reflection, rotation, and translation. Reflection, rotation, and translation, those type of transformations are called rigid motions, kind of like the robot. It's a dance move. Okay, let's keep going. We're going to switch over to 8.1D. So go ahead and turn to page 22. Go ahead and turn to page 22. I'm going to give you 2 minutes, no phones out, quick break before we get started. Okay, taking a look, 8.1D, page 22, the lesson is on congruence. We're just going to finish the next 2 pages to get a start. In the examples we've studied so far, we've applied only one transformation on a figure. In the following programs, you're going to perform a sequence of transformations on a figure. Triangle ABC has been plotted below. Perform the following transformations on the same coordinate plane. First, we're going to reflect triangle ABC over the y-axis and label the image triangle A prime, B prime, C prime. So let's label the y-axis. And what we saw last week is that when we are going over the y-axis, we're changing the x value. So it's going to be negative x comma y. What you can also do is you can count. They should be equidistant from your line of reflection. So B's 1, 2, 3, so B prime 1, 2, 3. A is at negative 6, so A is going to be at positive 6, sorry, A prime. And C is at negative 2, so here we go, C prime. And you can use your compass if you like to use a straight edge, but you should be able to sketch that pretty well. Now we're going to reflect across over the x-axis. And remember our rule for reflecting across the x-axis, x, y, we're only changing the y value. We're only changing the y, the vertical placement. So this is going to keep the same x and the y value is going to be the opposite. 1, 1, here's C double prime. B's at 4, so we're going to go to negative 4. B double prime, A is at 3, so we're going to go to negative 3A double prime and make our triangle. Awesome. But did you know we can have just one transformation that's the same as this double reflection? What do you think that one transformation is? That could be a flip over the y and then a flip over the x. Or we could just, that's right, a 180-degree rotation. What direction? It doesn't matter. So let's put both clockwise or counterclockwise. Counterclockwise. And it's important we always have to say about what? About our point of center of rotation. In this case, it would be about the origin. So that would take care of our blue rule and our purple rule at the same time. So let's do the same thing to number 2. First, we're going to reflect our original pre-image over the line x equals 1. So let's see, x equals 1, is that a vertical line or a horizontal line? If the x value is never changing, that's going to be a vertical line. X equals 1. So remember, if we're thinking about that rule, x, y, it is a translation of my y-axis. So I know it's my x value that's changing, negative x. And then it's translated 1 to the right, which means it would make up for 2 spots. And that's what we learned last class. So let's take a look, or you can always count 1, 2, 3, 4, 1, 2, 3, 4. There's E prime, F, 1, 2, 3, 1, 2, 3, F prime. D is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 to get D prime. How's that? Looks nice. And now we're going to reflect over the y-axis. So if we're going back over the y-axis, that's going to be xy is mapped to, if we're changing across the y-axis, it's the x value that's changing. And we're going to go over 1, 2, 3, 4. Oh, let's see, counting to the pink line. Let's do that again. 1, 2, 3, 4. 1, 2, 3, 4. Okay, F double prime. Let's look at E. It's a little closer. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do you see a pattern? Do you see a pattern? Take a look up here. We're only 2 to the, 2 to the left. Do you think that's going to be true with D also? Is this going to be where D double prime is? 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 8. Perfect. Oops, a little off there. Wow. So what's one transformation that's the same as this double transformation? Well, we saw that xy could have been mapped to what? X minus 2y, which is actually the answer for D. And this is a translation. How many units? 2 units. In which direction? To the left. To the left, to the left. Awesome. Let's turn the page. So our last page, we have a few more transformations. So let's take a look. I'd like you to work on number 3 and 4. I'd like you to work on 3 and 4, and I'm going to give you 3 minutes. Please pause the video for 3 minutes and finish 3 and 4. 3 minutes, number 3 and 4. Okay, let's take a look. Number 3. When we first reflected across the x-axis, we followed the rule xy is mapped to x comma negative y. Then when we translated to the right 9 units to the right, or use the coordinates, we notice we could have just done a 180-degree rotation to end up with the same. Pretty cool. And number 4, a translation, reflection, rotation are described as rigid motions. What's a rigid motion? What did you guys have? Did you have something about preserving the lengths of corresponding segments and the measures of corresponding angles? Did you have something about not changing the size or the shape? Well, we're going to look at this a little more closely on number 5. Number 5, we're going to use the grid to complete the following. Describe how the two figures are the same. Is there anything the same with my pre-image and my image? What's different? Then, can you describe a transformation or sequence that will carry A, B, C onto A prime, B prime, C prime, D prime? And then a different transformation or sequence of transformations. And then I want you to answer if the figures are congruent. So take 2 minutes real quick to answer those questions. Take 2 minutes real quick to finish 5. And I'm going to give you a special definition in part E, so keep your papers out. 2 minutes, please. Pause the video for 2 minutes. Okay. Some things you may have noticed that are the same are that corresponding segments have the same length and corresponding angles have the same measure. Notice I'm talking about corresponding, and angles I use the word measure, and segments I use the word length. I notice the shapes have the same shape and they have the same size. How are the two figures different? Their orientation, or you could have said placement or location, are different. One transformation or a sequence that carries A, B, C, D to A prime, B prime, C to prime, D prime is a 180-degree rotation clockwise or counterclockwise about the origin. And a different one could have been a reflection across the x-axis followed by a reflection across the y-axis. Could I have also gone across the y-axis and then the x-axis? Cool, that would work too. Are the figures above congruent? Why or why not? Yes. Two figures are congruent. And this is the symbol for congruent. It's an equal sign with a tilde on the top. Two figures are congruent. Any pair of two-dimensional figures are congruent if the second can be obtained from the first by a rigid motion or a sequence of rigid motions. And that includes any combination or single rotation, reflection, or translation. Again, any pair of two-dimensional figures are congruent if the second can be obtained from the first by a rigid motion or sequence of rigid motions, which are rotations, reflections, and translations. Excellent. You have the rest of the class period, if there is any, to finish homework. Do your best, be nice to everyone, and I will see you next time. Thank you.